So let me start by defining what a matrix is. So let me write it down. So an M by N matrix, and this is read as M by N, is a rectangular arrangement, of mn numbers into m rows and n columns. Okay, and so let me give you an example here. So let's take the example of a matrix A, which is, let's say, 1 2 3 4 5 6 7 8 9. So this is a 3 by 3 matrix because this has got 3 rows and 3 columns. All right, let's take the example of another matrix B and say matrix B is 3 4 minus 7 minus 1 1 6. Now this is an example of 3 by 2 matrix because this has got 3 rows and 2 columns. All right. An n-dimensional vector, right, represented by x1 x2 dot 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 xn. This is an n-dimensional vector, and this is an example of n by 1 matrix, right, because this has got n rows and 1 column. And an n by 1 matrix is also known as the column matrix, because the matrix has just 1 column. Okay, let's consider this matrix x1 x2 dot 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 xn. All right, so this is an example of 1 by n matrix because this has just got 1 row and n columns. All right, and a 1 by n matrix is also known as row matrix. It's known as the row matrix because this matrix has just 1 row of data. Okay, an element of a matrix in the ith row and jth column is traditionally denoted by aij. Okay, so let me give you an example. So let's say this number 9, right? So the number 9 is in the 3rd row and in the 3rd column. So the number 9 will be denoted by, say, A33. Okay, let's take the example of the number 1 over here. So now this number 1 belongs to the 3rd row and the 1st column, right? So this number 1 will be denoted by A31. Okay, and sometimes a matrix is also represented in this fashion. So let's say if matrix A is also represented in this fashion, aij. So what it means is that it's a collection or an arrangement of numbers aij, where I is the row and j is the column. So an important matrix operation is called transpose. So let me write it down. Transpose. And what transpose basically does is that the transpose of an, let's say, m by n matrix, and the transpose of this guy, if you apply the transpose to this matrix, let's say A, which is m by n, the transpose of matrix A, which is denoted by A with T on the superscript, A transpose T. Now this is another matrix of the form n by m. Okay, so if the original matrix A had m rows and n columns, the transpose of A, denoted by A transpose, will have n rows and m columns, such that the rows of the transposed matrix are the columns of the original matrix. Okay, so let me just give you an example. I understand this was quite a mouthful. So anyway, so let's say A is equal to, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. And now I have set out to find what is A transpose. Okay. So now we know that the rows of the transposed matrix are the columns of the original matrix. So the first column of A is equal to, so the first column of A is equal to 1, 4, 7, right? So that becomes the first row of A transpose. So this becomes 1, 4, 7. The second row of A is 2, 5, 8. Second column, sorry, of A is 2, 5, 8. And that becomes the second row of A transpose. So this becomes 2, 5, 8. And the third column of A is 3, 6, 9, and that becomes the third row of A transpose. So this is 3, 6, 9. Okay, so let's take another example to make things more clear. So let's say this time A is equal to 1, 2, minus 1, 3, and 0, 5, right? So A is a 3 by 2 matrix, right? So now let's try to calculate what A transpose is. Okay. So now what's the, so what's the first column of A? So it's 1, minus 1, 0, right? So this becomes the first row of A transpose, 1, minus 1, 0. What's the second column of A? That is 2, 3, 5. So this becomes the this becomes the second row of A transpose. So it becomes 2, 3, 5 over here. And A transpose is a 2 by 3 matrix, right? Because this has got 2 rows and 3 columns. Okay. So interestingly, we looked at the first column of A and then populated the first row of A transpose by the first column of A and the second row of A transpose by the second column of A, and so on and so forth. But you can also look at the first row of A and convert it into the first column of A transpose. So if you look at 1, 2, 3, right? So 1, 2, 3 is the first row of A, and if you look at the first column of A transpose, that is 1, 2, 3, right? So you can even work out the transpose this way also. So you look at the second row of A, that is 4, 5, 6. That should be the second column of A transpose, A 4, 5, 6, right? And so 7, 8, 9 also, right? The third row becomes the third column here, 7, 8, 9. And you can check it out even in this example. So the 1, 2 is the first row, right? And this becomes the first column here. Minus 1, 3 is the first row, and this becomes the second column here. 0, 5 is the third row, and this becomes the third column here of A transpose. Alright, so I'll see you in the next lecture when we will discuss about matrix operations.